We're moving on to section 9.3, which is called rotations. We're going to be looking at a few different things. First of all, drawing a rotation, but also being able to identify one. And then we're also going to be looking at how to identify specifically what the angle of rotation is and what happens when we have a composition of rotations. So we need to look at a few different definitions. First of all, when we're dealing with a rotation, it's going to be by a specific angle, in this case, angle X. So I could rotate by 45 degrees, I could rotate by 57 degrees. Whatever that angle is, that's called my angle of rotation, which is right here. The positive number of degrees a figure rotates. That's my angle of rotation. Now, just like in a reflection, if your point was on the line of reflection, it just stayed there. Here, if you are rotating and the point is actually on the center of rotation, which is the point about which you're going to rotate things, then it just stays there and it becomes like R becomes R prime. It doesn't move because it is the center of rotation, which is where everything is moving around. Every other point is going to be rotated by the angle of rotation. So like here we have V going to V prime by an angle X, which I would guess to be maybe like 50 degrees. Now W is also moving to W prime by that same angle, 50 degrees. And U is moving to U prime by a 50-degree rotation. So now one other thing that's really important, unless it is stated otherwise, rotations are counterclockwise. Rotations are counterclockwise, which is kind of counterintuitive because we're always thinking of moving clockwise, like our clocks, but it's different here. Rotations are going to be considered counterclockwise. Another thing that's important to recognize is when I'm rotating these things, so W to W prime, I'm keeping the same distance. So this distance from point R, which is my center of rotation, is going to remain the same. It's going to be equidistant. And then the last thing is when we rotate about a point, we have an isometry, which means I have congruent figures. Here we're going to look at drawing a rotation image. Now, we're not going to be drawing extremely precise rotation images. We're more interested in being able to recognize them, but you should know how to create these things. Because we're not going to be using protractors and rulers, we're going to just kind of be guesstimating what these images are going to look like. In the first example, we have this triangle LOB, and we're looking for a 100-degree rotation about C. Now remember, it doesn't say which way we're rotating, so we need to know that it's understood we are going counterclockwise. So just like when we were doing reflections, we're going to take one point at a time, rotate it the 100 degrees around C, and then we'll connect our dots at the end, creating our new triangle L prime, O prime, B prime. So I know that I'm going to be rotating 100 degrees. And if I think about angles that I'm pretty good at, like, I don't know, freehand drawing, I know that a 90 degree we draw pretty frequently, a 90-degree angle. It looks something like that. Okay, so now here I'm looking for an angle that's going to be a little bit bigger than that. So maybe an angle that looks about that big. That's like a 100-degree angle. Now it's not perfect, but we're going to get as close as we can. So let's start with O. I'm going to take point O. I'm going to draw a line to C. And now from that line, I want to create an angle that's a little bit bigger than a 90-degree angle. So I'm creating a line that's going to give me about 100 degrees. And I'm going to just extend that line pretty far so I can see where O needs to go. We learned on the last side that O and O prime must be equidistant from C. So I'm going to try to copy whatever this length is here over here. And I'm going to say it's about there that I'll be placing my O prime. So I've rotated one of my points by approximately 100 degrees. It looks a little bit bigger than a 90-degree angle. Now I'm going to take point L, and I'm going to do the same thing. Let me pick a different color. So I have point L. I'm going to draw my line to C. And then from there, I need to create an angle that's a little bit bigger than 90 degrees. So maybe like that. And again, I need to try to match this distance over here So I'm going to say about there is where I'm going to be putting point L. And then I also need to do point B. So again, I'm going to get a third color so we can see the difference. I'm going to draw a line from B to my, oops, let's undo that. That's not very accurate. I'm going to draw a line from point B to point C, which is my center of rotation. And then I'm going to create an angle that's a little bit bigger than 90 degrees. So about that. And I need to make sure that I'm transferring this length over here, which looks like I'm going to be right about there. So that I'm going to call my new B. And I didn't go back and put primes on any of these, so I'm going to do that right now before I forget. B prime, L prime, O prime. So this is my new triangle, and I'm going to outline it in black for you. I have O prime, L prime, B prime. So you can see that that whole triangle that we started out with, this triangle here, has now rotated around point C to my new O prime, L prime, B prime triangle. So I have one for you to try. You're going to do a 50-degree rotation. So when you're thinking about a 50-degree rotation, you're going to want to do something that's just a little bit bigger than 45 degrees. So I'm going to help you out a little bit here. Here I have a 90-degree angle. No, that's not quite 90 degrees. Let's try that again. There, that's more like 90 degrees. 45 degrees is perfectly in half of that. So 50 degrees is going to be just slightly bigger than that. So you're just looking for an angle that's going to be slightly bigger than this angle here, and that's how you're going to use, that's what you're going to use to do this rotation of triangle LOB around point B by 50 degrees. Okay, so now here we're looking at an image that we've been given, and we want to be able to identify the rotation of certain pieces of this picture. If you ever are given a polygon, they ask you for the center of it. The center of the polygon is going to be the point equidistant from its vertices. So in this example, I've got pentagon PENTA. My center is point X. It's right in the middle, and it's equidistant from each of my vertices. Okay, so if we're looking at problem number 1, well, A, we want a 72-degree rotation of T about X. So I want to take this point, and I need to rotate it by 72 degrees around the center of the pentagon X. Well, the first thing I want to do is I want to look at this pentagon. And I know that I have 5 sides, so that means here, around X, I have 5 central angles. If you think back to when we were dealing with polygons, we learned that you can take the central angles, which are always going to add up to 360, and you can divide it by the number of sides or the number of angles, since they're the same, to figure out what one central angle would be. If we do that for a pentagon, we learned that 72 degrees is the measure of one central angle. So I know that this is 72 degrees, this is 72 degrees, 72 degrees, 72 degrees. So if I'm interested in moving T by 72 degrees, I just need to scoot it over to the next vertex. But remember, you're always rotating counterclockwise, unless otherwise stated. So here, I just need to take point T, and I need to move it over by 72 degrees counterclockwise. So the image of T rotated 72 degrees about X would be N. So now we're also going to look at a segment. In part B, it asks you to rotate 216 degrees from Tn, so now I'm dealing with this segment Tn, about X. Well, if I know that one central angle is going to be 72 degrees, then to get to 216 degrees, I need to do that 3 times. Right, so let's check our math here. 72 degrees. If I do that 3 times, I get to my 216 degrees. So not only do I want to move Tn once to be this segment, I want to move it twice, 3 times. So I would end up with PA. PA would be the image of TN rotated 216 degrees. And I know that again because one central angle is 72, and if I move that 3 times, so here's my first rotation would be here, that's 72. My second rotation would be here, that's 144. My third rotation would be here, that's 216. And then you have this U-try problem down here at the bottom. You're going to take the image of E, and you're going to move 144 degrees about X. All right, so this problem is really similar because I'm going to be looking at a polygon, and I'm trying to determine my central angles so that I can determine a rotation. In the last problem, they gave you the angle of rotation, and you had to calculate where the points or segments were moving to. Here, they're going to tell you, well, hey, we want Q to rotate over to X. How do we do that? What rotation do we need to use in degrees? So what we need to do is we need to look at this picture, and I see that in this circle, I have my center C. From that center C, kind of like the pentagon, I have, let's count with a pencil, 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 central angles. So now in this example, I need to take my 360 degrees that make up that entire circle around the center and divide it by 9, which gives me 40 degrees. So I know that one central angle is 40 degrees. Okay, so then I look at how Q gets mapped onto X. And I see that from Q, I need to shift 1, 2, 3 vertices. So not only am I moving 40 degrees, but I'm moving that 40 degrees 3 separate times. So I'm going to take my 40, multiply it by 3, which gets me 120. So that's intuitively what I'm going to do. Now, that I went clockwise. So I would have to say 120 degrees clockwise to clarify. If I forget to say that word clockwise, now my answer is incorrect. The other option would be to go all the way around counterclockwise. So in which case I would have to go 1, 2, 3, 4, 5, 6. I would take my 40 times 6 to get 240 degrees. So I can either say 120 degrees clockwise, or I could say a 240 degree rotation, which implies the clockwise motion. All right, so there's 2 U-tries for you to work with there. So this last slide is talking about a composition of rotations. Now, right here at the top we see it says a composition of rotations, a composition of rotations about the same point is itself a rotation about that point. To sketch the image, add the angles of rotation to find the total rotation. So basically what it's saying is when I do 2 rotations, it's really just one larger rotation. So if I'm rotating, like in this example, by 30 degrees and then by 60 degrees, I might as well just start out by doing a 90 degree rotation, which was the 60 plus the 30. So if I add together my 2 rotations, that will give me my total rotation that I need to make. So let's do this example. I need to move 90 degrees. So I'm rotating by 90 degrees about K. Okay, so K is this point right here. It's part of my kite. I have to move everything by 90 degrees. So just like we did the example earlier, I'm going to start with point I, and I connect I to K, and then I'm going to create a 90 degree angle there. I need to make sure I map the same distance. So I'm going to say I is going to be about right there. So let's call that I prime. Now I'm going to take T. So let me switch colors. T, I connect to K, and then I need to create a 90 degree angle with that line. And I am trying to, that wasn't very accurate. I'm going to go back and try to make it more accurate than that. I need to take that line, make a 90-degree angle. There we go. And I'm going to map that same distance. So whatever this distance is, I need to make that same distance here. I'll say that that's going to be about right there. So I'll call that T prime. And then my last one, I'm going to take E to K, create my 90-degree angle. I like that second line that I drew better. This distance needs to be the same as that distance there. So, yeah, that's about right. So E prime. And now I'm going to connect my lines, or my points. I've got K, I, T, E, back to K. Now, because K was the center of rotation and it's also a new point, that K now technically becomes K prime as well. So there's my kite. I've rotated the entire kite by 90 degrees. I went counterclockwise, which is assumed if they don't say which direction to go. So then you have this last U-try problem where you are going to take just a single point and you're going to rotate it 2 90-degree rotations. So good luck with that, and I will see you in class.